Good day, friends. Let's continue to solve our problems on conservation of momentum and impulse, and also conservation of energy, of course. The problem statement goes like this. A ball of mass 2m is thrown vertically upward with a velocity of 10 meters per second. A weightless thread of length 1 meter is tied to the ball, and at the other end of the thread is a ball of mass m. After how much time from the beginning of the motion will the 2m ball hit the ground? A resistance is neglected. Okay. So to solve this problem, we must be able to imagine this problem. You see something like this, yeah? There is something like some ball which is 2m mass, and also another ball which is 1m mass, yeah? And they're connected with this kind of rope. Oops, I'm sorry. Like this one, yeah? And this has length of L. Also, we throw this ball upward, yeah? I have drawn this ball to be larger, of course, to imagine it better, but it doesn't have to be larger. It's just the density issue. Yeah, if the balls are the same volume, the same size, it does not mean that their masses have to be equal. It's the density issue. Yeah, and we throw only this ball upward, and of course the second ball will act on the second ball as maybe resistance, maybe like extra mass, and we'll see about that. Okay, so let's draw the situation. I would draw it something like this. Okay, so try to imagine. We have several processes. In fact, when we throw our ball, yeah, upward, let's imagine like this is our main ball, which is 2m, and when it goes up, yeah, at a certain height, it can lift to some certain height. Yeah, let me draw it like this point. It goes up till this point. Of course, after some distance, yeah, we just imagine it to be a large distance. Yeah, it might be 10 meters, it might be some small, just 3 meters. Yeah, it's okay. But we definitely know that at a certain point in this situation, this rope will start to act as a resistance. Yeah, we have here the smaller mass, which is m. But we know that this length is just 1 meter, right? It was said. And we know that the first 1 meter, this second ball will not act in the process at all. We definitely know that. It will seem to us like only we have thrown up only this first ball and it will not have any resistance at all. Okay, but after 1 meter, this mass will act as the extra mass. It will also disturb our mass to go faster upward, yeah, because it will pull it downward by its tension. Okay, yeah, let me choose, yeah, like this, yeah, okay. So we need to understand that we have here not one, not two, but 3 processes, and let me note them. First of all, the first distance is this one. This is, let's call it h0. The second distance is this distance. Let's call it h1. And the third last distance is this entire distance. It's h2, let's call it. Yeah. What's the meaning of this h? The meaning of this h0 is when distance, yeah, covered by only 2 meter ball without any resistance, without any extra mass, that it goes up without any problem, yeah? And we definitely know that it's only the first meter where it does not have any problem. However, the second part, yeah, the second h1, it will have some resistance, yeah, it will gain some extra mass. This mass will act as the extra mass to our first mass, and we definitely know that at some certain state this system will slow down, yeah, than before. Okay, and that's why let us note that at the very beginning, yeah, it's the velocity for this one, only for this ball. At the very beginning, it has a velocity of v0, yeah. At this point, yeah, well, it slows down due to gravity, and this will have some velocity 1. At the same instant, when this rope starts to pull it backwards, it will instantly transform into v2. And then, because v2 and also this will v2, yeah, because they will have their very own different velocity together, right? So what is it? v0 is the initial velocity of this ball. v1 is when this ball starts to slow down due to gravity. What about v2 and v2 again? It's the total velocity of when these two balls start to act as one system, yeah? Because at the very first situation, we don't take into account the mass itself, the first mass. We take into account only this 2m mass, but when after 1 meter, yeah, when it reaches the height of 1 meter, we definitely know that these two start to act together as 3m, because this is one system, right? Okay, I hope it's pretty much understandable to you. Okay, and let me note it with orange maybe, so you understand that this orange means they have together. Yeah, maybe something like this. No, let me choose some different color, maybe, yeah. Okay, so v0 and v1, as you can see them, they are red, which means that they are just for this this 2m ball. And what about this pink one is when they start to act as one system, when 2 balls start to act together, right? So here we'll have the last velocity at the very highest point, it's v3, and we definitely know that it will be just 0, yeah, because at the highest point it will not have any velocity, and then it will drop back to the ground, and then it reaches this last point again. So as you can see that it wastes some time for this, yeah, let's call it t1 for this process. Then it wastes some time for this process, which is t2, yeah, and here it wastes also one more time, which is t3. So if we want to know, as it was said in the given, after how much time from beginning of motion will the 2m ball hit the ground? So the beginning is here, and the ending point is also here. And we need to note that the entire total time, yeah, let's call it delta t, yeah, why not, delta t, it's time 1 plus time 2 plus time 3. Okay, yeah, good, good. I hope it's pretty much intuitive to you. I hope that you can understand it well. And a few more things to note. We don't know the meaning of this height. We don't know how much it will rise up, right? We don't know what's the meaning of the h2, of course, as well. But we definitely know that h2 is just h1 plus 1 meter, right? Yeah, we definitely know that. Okay, okay. Let's try to solve for this t1 when only 2 mass ball acts as this entire system, yeah? Okay, let's start it for t1, yeah? For t1, let's write it here. Okay, or let me note it not as t1, let me note it as first part, second part, and the third part of the problem, yeah? It would be better, because if I write t1, you think that I'm trying to find t1 straight up, but I'm not trying to find t1 right now. I'm going to it through several processes. Let's call it first part, okay? First part. We definitely know, we don't, okay, yeah, we definitely know this velocity, it was set. We don't know about this one, and we are given some height. Okay, I think that it's pretty much enough, because we have this formula, right? If you remember, v final squared, which is our v1 equals v initial squared, which is our v0 squared, and also plus 2a delta x, right? But it would be, in our situation, acceleration acts as gravity, and we know that gravity pulls us downward, that's why it will not be plus, it will be minus, and delta x will be our h0, yeah? And we need to find this v1 squared, yeah? v0, it was said that it is 10, that's why it will be 100, because 10 squared. Minus 2g, let's take it as 10, and h0 is 1 meters, yeah? We definitely know that. v1 squared equals 100 minus 20, it is 80, and v1 will be just square root of 80, which is about 894 meters per second. Good, good. Okay, do we have some space? I believe yes, and let's do it a little bit higher to have even more space. Yeah, like this, maybe. Yeah, good. Okay, right now we know the velocity of the ball, of this 2m mass, when it reaches the height of 1 meter, right? But it's only for this mass. We are not taking into account the mass 2 because it is not acting on our system yet. Okay, if we know that velocity, we can definitely find it by v final equals v initial, which is our v0, and plus at, as you remember, at, and t, it will be our time 1, because it's the first part, and if you remember it, this thing would be minus g t, yeah, right, because acceleration is our gravitational acceleration, and it is downward, it's a vector quantity. Okay, and to find time, it's definitely v1 minus v0 equals minus gt. If we want to make it positive, we multiply both sides by minus 1. This 2 will change its positions. This thing would be gt, and to find, yeah, this is 1, 1. And to find t1, we will have to just do something like this, v0 minus v1 divided by g. And we know the values. This thing has to be 10. This is 894. This is also 10 as well. So, yeah, let's continue. Here, t1 will be, okay, this is about 1.06 divided by 10. And this is about 0.106 seconds. Okay, good. So which means that only this 2m mass will reach the height of 1 meter at this at this amount of time. Yeah, this is a very short amount of time, and it's pretty logical. What about the second part? Let's try to work with it. We have found this first part, which is this one. Yeah, we have found time 1. We have found it. Let's note it with maybe green. Yeah, which shows that we have one of our answers. Let's work with part 2. Yeah, part 2. And if we look at this situation, let's try to analyze it. At the very instant, yeah, at just one instant, this v1 transforms into v2. Why? Because at this instant, at the very instant of the beginning of the situation, it was just 2m. But then it instantly transformed into 3m, because right now it has some extra mass, right? This rope and these extra mass started to work. They started to play their roles, and right now they act as some extra mass to our 2 mass. Yeah. Okay. How do we do it? We can call it as elastic collision, inelastic collision. Yeah. so we can do something like this. Conservation of momentum. Conservation of momentum goes like this. At the very beginning, we have what? 2 mass v1, right? This is the momentum in our initial state. And we know that there is conservation of momentum. Let me write it here. Conservation of momentum goes like this. Sum of all momentums at the very beginning is equal to sum of all momentums at the very end. And at the very beginning, it is 2m v1, right? Good. But then it instantly transforms into what? It will transform into this v2 and this 3 mass, right? This v1 transformed into v2. It instantly changed its velocity because we have now extra mass, and this extra mass gives us not 2m but 3m because we have additional mass, right? Okay, so it must be 3m, yeah, or you might write 2m plus m. I would instantly write it as 3m, and this will be v2, right? Okay, good. We can cancel those out, those masses, and to find the meaning of v2, we have to just 2 divided by 3, v1. And we know the meaning of v1. It's been found right here, right? We can find it by putting the values 894. It must be about 596 meters per second. Okay, good. We know the value of v2. Right now we know the value of v2. Okay, so when this rope starts to act with this mass together, yeah, they instantly decrease its velocity from v1 to v2. As you can see, it was 894, and right now it's 596. Right now it has changed its velocity. Right now it's less because we have extra mass, we have more mass. Yeah. Okay, good. And it will rise up at a certain height after some amount of time. We know that the final velocity has to be 0, and we have this velocity. Okay, and I think that would be pretty much enough. Yeah, let's try to find that h first. Okay, or let's try to find time. Yeah, let's try to find time too. Why not? We know the value that the final velocity, which is our v3 in the second part, initial velocity would be v2, and this thing has to be minus gt2. Yeah, the same process as before. I think that we don't have to repeat it. Yeah, this would be v3 minus v2 equals minus gt2, and we have to swap their places. v2 minus v3 equals gt2. Yeah, and time 2 would be just, would be equal to v2 minus v3 divided by g. Okay, we know that v2 is our 596. This is just 0, yeah, at the very top, as we have told you. This has to be just 10. So which means that time 2 would be just 596 divided by 10, and we just move this comma just 1 before 5, yeah, just like this. Seconds. Okay, to reach the highest point, it wastes a little bit more time, as you can see, and we have found the meaning of time 2. Okay, good. Good. And we have found time 2. This one. Okay, we can move to the third part, but first let's work still with the height one, and it would be not that hard because we have right now lots of values. So it would be something like this: v3 squared equals v2 squared, because this is our final, this is our initial velocity, yeah, in the second part, only in the second part, minus 2gh2, no, h1, yeah, because at the very beginning we had h0, yeah, and right now it's h1. Okay, we know this is 0. We know that this thing has to be 596 squared minus 2g is just 10, and this thing has to be 1. If we move this thing to that side, it would be minus, but we have minus here, and minus minus, we can do it positive. We can make it positive. This thing has to be 596 squared equals 20h1, and h1 will have the meaning of 596 divided by 20. This is squared. Yeah, we definitely know that this number has to be larger than 25 because it's larger than 5. It would be something very close to 36 because this number is close to 6. But if we calculate it, this thing has to be about 177 meters. Yeah, this is height 1. This is not the entire height, it's only this part. But if this part, right now, we have found it, if the height 1 is 177, and we know that height 2 is height 1 plus 1, then it has to be, just the simple maths, h2 has to be 177 plus 1. Then h2, the entire height, the maximum height, would be 277 meters. Okay, good, good, I like it. Okay, and let's do the last part, the last time. It would be something like this. Okay, the third one. Yep, good, good. Okay, it starts with v0. It passes this entire distance. We are not interested in the last velocity that it would hit the ground. We're not interested in that, but we are interested only in time, and we know the entire height. Let's try to use this formula that we know from kinematics. If you remember that thing, x final equals x initial plus v0t plus at squared divided by 2. I hope that you remember that. If we move it here, this thing has to be delta x, yeah, delta x equals v initial time plus at squared divided by 2. Okay, this is for horizontal because it is x-axis. What about the y-axis? Instead, for our delta x, yeah, the last position, we know that delta means x final minus x initial. But our x final, yeah, our final height is just 0. This is our final height would be 0. Our initial height is that entire height, which is 277. Then 0 minus 277, it gives us minus value. Yeah? This has to be our minus h. Yeah, this has to be our minus h2, the entire. Okay, what about the v0? Our initial velocity is this v3, which is 0. That's why we don't concentrate on that. We don't have initial velocity. And we have minus gt, yeah, minus gt squared. This would be our time 3 divided by 2. And as you can see, both things are negative. That's why we can do them positive. And to find time 3, it would be very easy. This is squared. This would be 2h2 divided by g. And to find t3, we just need to take it to square root. 2h2 divided by g. And this would be 2 multiplied 277, the entire height, divided by 10. Right? Okay, good. And time 3 has to be square root. This thing would be what? 554, if I'm not mistaken. I hope I was not mistaken. This is divided by 10. This is square root of 0.554. And this would give me some number like 0.74 seconds. Okay, this is our time 3, the last time that we were meant to find. It's the time that it wastes on this entire height. Yeah, and we have found t3. We have found t3. So if we put the values in, yeah. First, let me choose some different colors. Maybe let's choose it as orange one. Let's make it maybe red one. So why am I doing it different colors? I want to show you something, just you don't get distracted. So if somebody could not understand till this time what is happening, time 1, it is this part, 0.106 seconds. It's the time that we waste on this part. And time 2, it's the time that we waste on this part. This part. And last thing, time 3 is that time that we waste on this part. And if we want our ball, this one, to start here and then move this entire part, it has to do all the processes. The first one, then the second one, and the third one, right? I hope that it's pretty understandable to you. And we just have to collect all those times together. Then we would have our delta time, and this would be 0.106 plus the second time was what? The second time was 0.596, and the last one 0.74. Yeah, is it? Yes, good. So our delta time would be what? This thing would be 0.702, if I'm not mistaken. Yeah, I hope I'm not. This would be 0.74, and this has to be 1.44 seconds. Okay, this is the entire time. This is the entire time, maybe with yellow, yeah, of our 2M ball to pass from the very beginning to the very end. Okay, I hope that it was understandable to you. If you didn't understand, you can write me privately, and I will try to explain it to you as best as I can. Thanks for your attention. Goodbye.